Hello there, taxidermists and gentle peeps. This is Neil here from Digital Taxidermy, and I'm here for the start of a new series where we're going to take a look at how to improve the quality of your models. Some ideas of what you can do, things that you should consider when you are creating and manipulating new models. So here we have something that's going to be coming out fairly soon for us. This is an industrial vent chimney. So this is a two-part model, which you can see here. We've got the base piece and we've got the top vent. And these will be available soon on our Patreon, the Digital Taxidermy Buyers Club. It will then be, that will get you some early access, and then that will go live on our website. So in here I've used several techniques that we've been working on over the time that we've been running to try and make this not only a good looking model but print supportless and be relatively easy print for everybody. Now, in order to make this supportless, with this shape and with this vent grill here, it's currently in two pieces, as you can see. We've got the bottom piece here and the top piece here. These were created using SolidWorks and Inventor, and then transferred, test printed, and away we go. All right. So first thing you'll notice is that it's all hollow. It's very thin. I do this a lot with all my models. This is to reduce the amount of filament that is used. So we keep the filament down to a minimum. No need for infill, no need for anything. Now, I know this is a ventilation tube, and so with a ventilation tube you wouldn't expect there to be anything on the inside, but as the series goes on, I do have some buildings and things that I can show you, which will give you an idea as to how I approach some of them as well. You will notice that they are all hollow, zero infill, a lot of good things going on there, and we'll talk more about those in later episodes. Up here in the grill, this all uses bridging, and this is another thing that we'll go into in more detail in future episodes. I use this quite a lot for flooring, vents, and nifty little details. You'd be surprised what you can actually get away with these grills. They can cover quite a large area, and actually they're quite strong. There's a few considerations when you're doing them, and it all comes down to numbers. So what you've got to think about is what your key audience is going to be using, and in most cases people will be printing with a 0.4 nozzle. So taking 0.4 nozzle and a 0.2 layer height as standard, which is what we'll do whenever we're making terrain and such. So using those two numbers as a basis, we will use that to dictate sizes, widths, and everything with regards to shapes and forms. So layer heights of 0.2 means that we're going to be working in 0.2, 0.4, 0.6, 0.8 and 1 and upwards, you know, whenever we're using height dimensions. And then when we're working on the X and Y plane, we're going to use multiples of 0.4. Now, the minimum that you really want to use with anything is 1.2 millimeters. 1.2 millimeters gives you three line widths, three nozzle widths at any one time on your X and Y plane. So each layer that goes up will have three lines, three more lines, three more lines, and that's about the minimum that you want. you see here we've got some very fine details. For fine details to come out, these need to be a minimum of 0.8 millimeters wide. If you do 0.4 millimeters, then you'll find that the slicer will stutter. So it will come along the wall and then it will stop, retract, and then put a little blob there and then retract and go back. And what that does is causes excess heat to build up inside the hot end, which can cause clogging, it can cause gaps in the walls, and generally endangers the print from being easily replicable. If you have 0.8 millimeters, then the nozzle can come along, push out, around, back into the main skin without having to stop and retract, which means it doesn't stutter at all, which gives you a much better surface finish. So 0.8 is your minimum for vertical lines to be able to be reproduced properly. The other thing is you get a better fidelity on the Z-axis. So horizontal lines can be reproduced at a minimum of 0.2 millimeters. There is no real maximum on that. You can increase it as much as you like. The next consideration is, of course, these have to fit together. So there is a tolerance involved in that. And usually I go for about 0.25 millimeters to 0.5, depending on how tight the fit needs to be. This particular one is 0.25 off of every surface, and that gives it a nice tight fit. You might need to push it in a little bit on the first time you try it, and it will hold. In that case, you won't need to completely pull it out. You won't need to glue it in or anything. So now we've had a quick look at that model. You see on here the wall thicknesses. So I'm going to show you an example of the test print and the final print. Now I started off working on a principle of 1.2 millimeter wall thicknesses, and this is 3 perimeters all the way around. Use as minimal filament as possible, and you know, it saves material, it prints faster, and it will be lighter. Now what I actually found was, if we see here, we've got the first print on the right hand side and the remedial print on the left hand side. And you can see here you've got all these lines that appeared, like really thick ridges and oozes and everything. And you know, I thought exactly the same thing. Check your E-steps, check your belts, check your Z screw. So I did all that, and I did another test print. It came out exactly the same. So back to the drawing board. I let it go up to this point, and you can see here the quality changes considerably when it reaches this point, and that's because it's thicker than 1.2 millimeters. So after printing this out, and I mean it was a fairly successful print apart from this wall quality. So the top piece as well printed out, and it was quite hard to fit because of the ridges and inconsistent printing. So I went back to the drawing board. This little bit here is a bit of the brim. Haven't trimmed that off. We can see, let's have a little closer look here. You can see those ridges again on both parts there. It's a real mess. You see here on the left, nice and clean, nice and clean. And the same on these here, much better quality on the left. Yeah, you see the brim around the edge there, which is the direction that was stuck on the build plate. So I came back to the main model after playing with these, and so after coming back to the main model, wherever it is, camera, SolidWorks not responding. There we go. And I increased the wall thickness from 1.2 millimeters to 1.6. And I found that having 4 perimeters for your main body is the ideal minimum thickness. So you can see in here we're just in Cura. The model's been put on to slice. We just slice that. We'll do a little preview here. That's an excessive brim. We've had a little bit of filament lately that is causing adhesion issues that, you know, it shouldn't do. So we'll just slice that again without the brim, so we can get a better idea of what's going on. You see this is printing on the base here, and all this grill is horizontal, which is very important to the success of that coming out. It doesn't need to be on the base itself. It's just it's free floating. It's done with bridging, and then we can pull this down to examine some of the layer lines inside. We've got ourselves some support on as well. Haha. Go, just reslice that again without the support, makes it clearer. You do not need support for this. It's a completely supportless model. It's been designed as such. So what we actually get here, so this has a 1.6 millimeter wall thickness, but because of the limitations of printing and all these curves and things like horizontal expansion and the gaps in between the lines, it's only actually drawing 3 perimeter lines through most of it. So you can even see here on these sides that it's doing a thin line. So it's kind of moving fast and extruding the same amount. You can sort of see here in the corners. So it's moving fast and extruding the same amount to enable it to put out less filament. If you are using 1.2 millimeter thick walls and you've got all these curves going on, you'll find that it won't have enough room, so you'll get it pushing out lots of filament inconsistently in the central wall, and that is what then causes the over extrusion appearance on the outside of it, which we can see here on the right hand one. And it's not over extrusion of the printer itself. What it is as it's just sort of dotting bits of filament in the interior wall, it means that the facing wall has nowhere to expand to, and so any inconsistencies in there are amplified tenfold on the outside, giving it this horrible finish. So just by increasing the wall thickness by 0.4 millimeters, you can make an exponential difference in the appearance of the print. Now, obviously, your printer calibration is going to play a part in this. However, model design in itself is going to be a big thing. All of these models then get exported to STLs. We run them through 3D Builder to check for any errors from the exporting process, and then orientate them so that they are in the correct position, so that all you have to do is take that STL, drop it into Cura, slice it, and print it. Away you go. So that's a little look at the way that you can consider wall thickness in relation to your nozzle size for successful model design for minimum filament. Anyway, that wraps up this little chat about how to consider numbers in your design work. I hope you've enjoyed it. Let us know in the comments below if there's anything in particular you're having trouble with modeling, and I'll catch you next time. Have fun. See you later. Bye bye.
Like the video, follow me around. Press the bell, it makes no sound. Like the video, press subscribe. I don't know why